All right, so I finished my general announcements, and that included highlighting the fact that CFU number 1 can be made up today or tomorrow. It can be retaken starting this Thursday until next Thursday. And homeworks 1 and 2 are going to be due next class on Wednesday, September 4th, with homeworks 3, 4, and 5 being collected next week on September 10th. Finally, CFU number 2 is this Thursday. And if you're not here this Thursday to take it, you'll have Friday and Monday next week to make it up, and it'll be passed back on Tuesday the next week. All right. Students were already given some time to complete the multiplication at the top of page 11, and this is the answer key to those. We're going to start, as I said, with a warm-up problem that reaches back to older material. This is what was practiced on the previous CFU. And keep in mind, even though, yes, you've already taken the CFU, we have a test at the end of this unit. Every time we finish a note packet, we're going to review and take a test. So even though we've already tested on this with a CFU, that doesn't mean you can just forget about it, because you still need to know how to do this for our first test of the year, which is coming up in about 2 weeks. Okay? So can anyone remind me, what is the first thing we should do with our calculator? What is it? Clear it, reset it. Okay, so second plus 712. That's the first thing that we should do. Okay? I don't know why this thing is in my way. Let me see if I can get that to shrink down for me. All right, that's better. All right, now I'm going to go to y equals, and I'm going to type in the equation square root of x minus 1, and I would invite you to do this with me, folks. So after you reset it, go to y equals. Remember, to get the square root symbol, you hit the blue key first, because that's the color of the square root symbol, and then x squared. Second, x squared. And then you can type x minus 1. This is the graph that we want to use to fill in the table. Now, if you hit graph, you can see a picture of the thing that you would want to be able to build. Fortunately, that's not part of today's warm-up, so we don't really need to worry about that. But if we go to the table, so if you hit second graph, I actually really like that there's this error message here, because it relates to the idea of domain and range that I want to teach you all today. A lot of students think that when they see that word error, they must have messed up. But you didn't. In fact, if you back up, you're going to see nothing but a bunch of errors. And that's not because you did anything wrong. It's because if you look at the graph, it literally doesn't exist when x is negative. It starts when x is equal to 1. So anything less than 1, such as 0 or -1 or -2 or -3, the calculator reports an error, and that's just the way the calculator's way of saying the graph isn't even over there. There is no function over here on the left, okay? And we're going to talk about this today. We're going to talk about how the domain of this thing starts at 1 and then just shoots off to positive infinity forever. That's part of the new concept I want to teach today. So if that doesn't make sense yet, don't worry about it. Now, what we actually want to do is fill in this table, and the directions say use whole number values, no decimals. So if I go down in the table, I'm going to copy the point 1, 0. I'd invite you all to write that down now. 1 and 0. Then 2 and 1. Keep going down. I've got 5, 2. Can anyone tell me what the next point is? Thank you. Can anyone tell me what the next point is in the table with all whole numbers? 10, 3. You got it. If you go all the way down, you'll find 10, 3. And if you go down even further after that, you'll find 17, 4. Those are 5 points, and the directions were write down 5 points. Now, if you wanted to keep going, if you wanted to scan down the table more, you could get 26, 5 or 37, 6 or 57. I mean, it doesn't stop. It just keeps going and going and going and going. Okay? But the directions were get 5 points. So once you have down to that 17, 4, you follow directions, you're good to go. Now, this is, again, pretty much exactly what your CFU was like last week on Friday, with one exception. On the CFU, you had to graph the points in order to provide a sketch of the function. That was the other part of the CFU. And I'm saying this for people who might have missed it. Okay? Questions? Hey, that was not what I wanted to click. All right. So I asked students to turn to the next page, and this is where the notes for today are going to start, and then we're going to get to just practice examples over and over again. So the domain is all possible values that can be substituted into the function, or what we refer to as the x values. Now, basically what we're going to ask ourselves is how far to the left and how far to the right does this function go? That's what domain is. It's how far to the left and how far to the right does this thing go. For example, the square root function that we just graphed a moment ago, the farthest to the left it goes is at an x value of 1. It doesn't go any further left than that. It stops at x equals 1. But it then shoots to the right and it never stops. It just keeps going and going and going and going. We have a word for that, by the way. Does anyone know the mathematical term for a number that just never stops? It just keeps going? Infinity. That's one of the blanks down here. Okay, so what we would argue is the domain of the function we did in our warm-up, 1 to positive infinity, because it starts at 1 and then it just goes to the right forever. Now, range, I'm sure you all might guess, is all of the y values. And this is how far up and down does the function go. Now, so look at it from the bottom to the top. How far down does it go? How far up does it go? Now, in the case of the function we just did in our warm-up, okay, this thing never goes down into negative values. If you notice that, it stops at that point 1, 0. It never reaches down into negative values. So the lowest down this function can go is 0. But it keeps going up forever. I know it looks like it's leveling out, but as it's going to the right, it keeps going up and up and up and up and up, and it never stops going up. So it goes as far down as 0. It goes as far up as positive infinity. That would be the range of this thing. Okay. Now, some things go down forever, so we do have a symbol for negative infinity. And by the way, the infinity symbol, I like to think of it as just a figure 8 that's been turned on its side. That's what I think about when I want to draw infinity. I just think of drawing the figure 8, but flipped on its side. Now, I'm not going to read through the bottom of this page for y'all. In fact, I would recommend you write yourself a little note and you just label this, read this later. The reason I say that is because I want to spend the rest of the period just showing you examples. I think this is the type of thing that makes sense if you just see a lot of examples. Okay, so what I would recommend is understanding that if you read this right now, there'd be a lot in it that might be hard to understand. But if you, after you've seen a bunch of examples, go back and read this. Spend like 2 minutes just reading through this. And my guess is this will make perfect sense. Okay, and I would argue that probably the most confusing thing for students is the different symbols. Why would I use a parenthesis and why would I use a bracket? You know, I would say that's the single most confusing thing for students in what I'm about to show you. Okay, but I'll try to communicate that. All right, go ahead and turn the page. So literally all we're going to do for the rest of the period are examples on page 13, examples on page 14. Now, I tried to create 2 different families of examples. I have one group, which is on page 14, where you have graphs that end on points. So you have graphs that stop. But the graphs on page 13, you'll notice they don't have points at the ends. And that's they keep on going. Okay. So this is a group of graphs that just keep shooting forever. And then the next page is a group of graphs that stop at points. You experience both when we're talking about domain and range. All right, so the directions on page 13 say, complete the following 3 items for each graph shown below. Use the word bank below to identify which basic function is shown. Okay? So I don't expect you all to know this right now, but these are 6 graphs that we're going to see so often that my hope is you all will be able to look at these and just know what they are. In fact, I'm hoping somebody might recognize one of these. Can you know what any one of these graphs might be called? And you have the word bank at the top of the page to help you. I heard slope, but that's not one of the items in the word bank. So you have these options. They're all different types of functions. Can anyone tell me one of these functions? We've used the V a lot already. We've graphed. Which type of function is that, folks? The absolute value. You got it. So this is one that I would expect you all to recognize very quickly. Okay. Now, as the course goes on, yes, sir. Did you say square or square root? Perfect. This function here is the square function. That's the other one that I would hope people would recognize. We've seen those two functions a lot. Now, I'll admit, identity is kind of a weird word for that first function, but I think that'll make sense when I circle back to the equation. Okay, so we are going to see the identity function, the absolute value function, the square function so much throughout this year that not right now, but eventually I want you all to be at a point where you can look at that graph and just know, oh, that's the absolute value function, or that's the x squared function. Okay, and when I say x squared, I literally mean y equals x squared. Okay, and when I say absolute value, I literally mean y equals the absolute value of x. And for the first one, identity is just because it has no numbers, no multiplication, no symbols. It's just y is x. That's why it's called the identity function. Now, the other three we haven't seen a ton of, although we did see the one in the middle in our warm-up. Anyone tell me which type of function that middle one is? We saw that shape in our warm-up. What type of equation did we do on the previous page, folks? What was that equation we did back on page 11? This is where you could turn back to page 11 to figure out the answer to the question I'm asking. What's that one in the middle, folks? Thought I heard it. Square root. This is actually why earlier when I heard square, I wanted to make sure. Did you say square or did you say square root? Because there are two different things. This middle one, which is what we did for our warm-up, is a square root function. It's y equals the square root of x. Now, the other two, I don't expect you all to recognize right away. We really haven't done anything with those much at all. So those I'm just going to give you. D is the cubed function, y equals x to the third. And f is the cube root function, which is y is equal to the third root of x. A lot of people don't realize this, but just like with exponents, like with powers, you can put numbers in a square root to communicate which root you're trying to take. You know, the only one we don't bother writing is the 2 on square root. There is technically a 2 there, but we don't really bother writing it. When you write the symbol, people just assume it's the square root. It's the second root. Okay. All right. So if you've been keeping up with the notes, we've done the first two parts. We use the word bank to identify the function. We provided the parent function for the graph. And like I said, I don't expect you all to have these memorized right now, but we are going to encounter these 6 graphs so much throughout the entire year that if you can get to the point where you can look at that graph and just know which type of function it is, it's going to help you. Now, the third and final step says provide both the domain and range of each function. And let me remind you, when you're talking about these things, domain is just how far left and right. Range is just how far up and down. Okay. Now, the reason I created this group of graphs is because they keep going. So I want you all to add arrowheads to remind yourself of that. This function, it keeps going down and to the left. It keeps going up and to the right. This function keeps going up to the left and up to the right. This function keeps going up to the left and up on the right side. Add those arrowheads to remind yourselves these functions don't stop just because the paper stops. They do keep going. Now, the one exception to that on this page is graph E. The only exception to this, like D, it goes down and to the left. It goes up and to the right. F, down and to the left, up and to the right. But E is an exception. E, while it goes up to the right, it stops right there at the origin. It does not keep going to the left. It does not keep going to the right. The function stops there. Okay. Now, because all of these functions just keep going and going and going and going, the domain and range for a lot of them are exactly the same. For example, if we're going to focus on domain, how far to the left does the function go? How far to the right does the function go? Every single one of these functions, except for E, goes all the way to the left and all the way to the right. I'm trying to zoom out so you can see all 6 at the same time. If you ignore E for just a moment, let me just cancel that one out for just a moment. If you ignore this graph, every other graph, when you look at it, it goes all the way to the left and all the way to the right. Now, sometimes when it's going to the left, it's going down. And sometimes when it's going to the left, it's going up. Sometimes when it's going to the left, it's going down. Sometimes when it's going to the left, it's going up. But the point is, all of these 5 graphs go all the way to the left, all the way to the right. So when you're describing the domain, what you want to say to me is that this thing goes all the way to negative infinity and all the way to positive infinity. Literally, that's the domain for every one of the graphs on the top. It's also the domain for D and F on the bottom. $40. Now, E is the one exception. E is the only exception when it comes to the domain. This function does not go all the way to the left. Okay? If you notice, this function doesn't exist over here. There's no curve over there. It stops at 0. Or if you want to think of it another way, it starts at 0. You want to help your neighbor out right behind you. Thank you. Okay, so the domain for this one, it starts at 0 and then goes to the right forever. Now, here's where I might potentially confuse some folks. This is important, and it's something I'm going to clarify on the next page, the last page we're going to get to today. Notice I put a square bracket around the 0, but I put parentheses around infinity. Okay, I'm going to clarify what the heck is going on with that on the next page. I'm not going to worry about trying to explain it on this page. Okay, but notice there is a reason I put a square bracket around the 0 and I put a curved parenthesis around the infinity. There's a reason for that I'm going to explain on the next page. All right, that's the domain. We talked about, or I've talked about how far left and right. Now let's talk about how far up and down we go. Okay, here's what I'm going to do for this. Again, I want you to be able to see all the graphs at the same time. If you ignore this graph and this graph and this graph, just ignore those 3 graphs for a moment. Look at the other 3 graphs. The thing that they all have in common is that they all go down forever somewhere. Okay, I know this one right here looks like leveling out, but as it goes to the left, it's going to keep going down, 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 down. It's going down forever. Okay, so graphs A, D, and F, they go down forever, but they also have a part that goes up forever, up forever, up forever. Okay, so this is what range is meant to describe. Range is meant to describe how far up, how far down do you go. So for graphs A, D, and E, it's all the way to negative infinity, all the way to positive infinity. So that's what I want us to write next. Go all the way to negative infinity, all the way to positive infinity. Negative infinity, positive infinity for A, D, and F. Okay. Now, I'm going to ask you, now that we've done A, D, and F, I'm going to ask you to ignore these 3 graphs that we just finished for just a moment. Because the other 3 graphs also do kind of the same thing in the up and down motion. If you look at B, C, and E, they're all doing slightly different things, but the thing that they have in common is that none of them reach below 0. This thing does not reach under 0. This does not reach under 0. You know what? Let me do this with a different color. This does not reach under 0. This does not reach under 0. This does not reach under 0. Everybody see what I'm trying to point out? When you're talking about how far down and how far up does it go, the lowest all 3 of those graphs go is 0. They stop at 0, but they don't go any lower. But they also all shoot up forever. So their range is going to be 0 to positive infinity. Let me get rid of all my crazy crossouts here. 0 to infinity, 0 to infinity. I'll zoom in on this. 0 to infinity. And notice again, the 0 has a square bracket around it. The infinity has a curved parenthesis. Again, I don't expect that to make sense until we get through the examples on the next page. All right, so to repeat something I said earlier, we've now finished the first cluster of graphs, and I specifically selected these because they all have this common feature that they shoot forever somewhere. They shoot to the left forever, or right forever, or up forever, or down forever. But now I want to show you, again, trying to teach you the idea of domain and range. I want to do it with examples on page 14, examples that stop at a point. Okay? So go ahead and turn the page. Now, here's something I'd like you to add to the top of the page. If you see a filled in point, this is called closed, and it means you should use square brackets. But if you see an open point, this is again referred to as open, then I want you to use parentheses, curved parentheses throughout this page. You're going to see me use a bracket, or you're going to see me use parentheses. And I want you to understand that's a decision I'm making based on the point that's available. Okay? Now, to try to explain the idea of the difference between a closed and an open point, let me sort of talk about this a little bit. Okay? Imagine, let me start with the open point for just a moment. Imagine I am standing 10 feet away from the door of the classroom. My plan is I'm going to cut that distance in half. If I cut it in half, I'm now standing only 5 feet away. Then I cut my distance in half again, I'm 2.5 feet away. I cut my distance in half, I'm 1.25 feet away. I cut my distance in half, and I cut my distance in half, and I cut my distance in half. If you think about it, I'm never actually going to touch the wall. If my plan is cut your distance in half, 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 you never actually touch the wall, because no matter how close you are, you're not going the whole way, you're just getting halfway there. Does that make sense? Okay? That's sort of what an open point is saying. Notice this point reaches as high up as 5. But because it's an open point, what that means is this function never reaches up and actually touches 5. It just gets really, really, really close to it. So that open point is telling you, okay, yeah, we're getting closer to 5, but we can never actually touch it. So we get to 4.999999999999999. Does that make sense? But you never actually touch 5. Now, the point down at the bottom is a closed point. That means you touch it. That is, there's the front wall, and I'm going to walk up to it, and I'm going to touch the wall. Okay, that's a closed point. So this point down at the bottom, it's as far down as -4, and because it's closed, we actually get to -4. Okay, so the way you communicate this, I was talking about up, down. We got as high up as +5 without touching 5. And we got as low down as -4, and we actually touched -4. Notice this is the range. Please don't write this in for domain. I was talking about how far up and down we were going, and range is your up-down motion. Now, if I wanted to talk about domain, in fact, here's something I like to do to kind of help myself with this visually. I imagine a box around the entire function. And then I just ask myself, how wide is that box? How tall is that box? That's basically how I help myself think about domain and range. So that box, it goes as far to the left as -5, but that's at a hollow point. So it doesn't actually touch -5. And it goes as far to the right as 0, and that's a closed point. So it touches 0. So my domain, it goes as far to the left as -5 without touching -5, parenthesis. And it goes as far to the right as 0, and it actually touches 0. So that's a bracket. Okay. I'll worry about, by the way, I'll worry about the inequality notation. Honestly, probably next class. I'll probably hold off until next class to reveal that. But the directions say list the domain and range of each function in both interval notation and as an inequality. We're just going to do the interval notation for domain and range. Now, let me do one more example, and then I'm going to ask you all to try one yourselves. For the next one, again, what I like to do is I like to imagine a box that traps the entire function. And then I just ask myself, if I'm doing domain, it's left and right, If I'm doing range, it's up and down. So let's start with left, right. This box, this function goes as far to the left as -3, and it includes -3. It goes as far to the right as +4, but it does not include +4. Now, in terms of up and down, this thing goes as low down as -5, and it goes high up as 3. And notice there's no open point there. There's nothing saying that it doesn't actually touch 3. It's a curve that goes up, hits 3, comes back down. So we hit -5. We also hit +3. Oops, wrong one. That's for tomorrow. Okay, so it goes as low down as -5. It goes as high up as +3. And both have square brackets because it actually touches at those locations. All right, I'm going to put a 1-minute timer on the board. I'd like you all to try example C yourselves. I'm going to put this box up to visually sort of assist you. Remember, domain is left, right, range is up, down. Take a minute, see if you can answer that one. Go. All right, folks, so for domain, this thing goes as far left as -3, as far right as +4, and you should have had brackets on both because both of the ends are closed points. They're included. For range, it goes as low down as -3 and as high up as +2. So this would be -3 to +2, again, both with brackets, because it actually includes those numbers. Questions? All right, I'm going to do 2 more examples, and then we're going to end with you all trying one yourselves, and we'll call it a day. All right, so for the next 2 examples, in fact, I'll just go ahead and reveal the boxes for all 3. These are sort of the boxes I use in my head to help me with domain and range. Okay, remember, domain is left, right. So with the first one, it goes as far left as -5 and as far right as -1. So this is -1 and -5. With the next one, it goes as far left as -2, as far right as +4. So that's -2 to +4. Now, in terms of up, down, the first graph D goes as low as +1, as high as +5. So that's 1 to 5. That should definitely be a bracket, though. So I'll have to retype that. I thought I caught all these. Sometimes I make copy-paste errors. That does actually reach as high up as +5. Blue. There we go. Bracket. I'll do that later. All right, and for the next graph, it goes as low down as 0, as high up as +3. So 0 to 3. Looks like I have the same copy-paste error again. Come on now, Mr. Oben. All right. Now, I want you all to do the last graph yourselves. Do graph F. Notice that it does have hollow points. Okay. Take 1 minute, and then I'll post the key to that, and we'll call it a day. I'm just going to make sure I get that one last note in recording. Because the picture is unclear, if you thought the curve touches the x-axis, then use a bracket. But if you think it kind of came down and didn't quite touch the x-axis, so it didn't actually hit 0, then use the parenthesis as I already have pre-typed. All right, we'll finish this page as part of tomorrow's class. Thanks for watching. Have a good one.